Howdy. We will start off this video with a quick read about potassium oxide. And hopefully I can explain you why in some time. Why this potassium oxide is something very interesting. K2O is an ionic compound of potassium and oxygen. It is a base. This pale yellow solid is the simplest oxide of potassium. It is a highly reactive compound that is rarely encountered. Some industrial materials, such as fertilizers and cements, are assayed assuming the percent composition that would be equivalent to K2O. Potassium oxide is produced from the reaction of oxygen and potassium. This reaction affords potassium peroxide, K2O2. Treatment of the peroxide with potassium produces the oxide. Alternatively, and more conveniently, K2O is synthesized by heating potassium nitrate with metallic potassium. Let's go still a bit down and read a bit more. K2O crystallizes in the antifluoride structure. In this motif, the positions of the anions and cations are reversed relative to their positions in CaF2. Calcium phosphide? I don't know. With potassium ions, calcium fluoride. Okay. With potassium ions coordinated to 4 oxide ions and oxide ions coordinated to 8 potassium. K2O is a basic oxide and reacts with water violently to produce the caustic potassium hydroxide. It is quenched and will absorb water from the atmosphere, initiating this vigorous reaction. So we have to assume that somewhere on Earth there is some amount of K2O present. And yeah, that's rather hard to explain all the stuff which relates to that, but I've been very much talking about the surface conductivity anomaly of Scandinavia. Let me show you a picture of that in a second, but we have to read something about basic oxide. Now let's put this into the search here. Basic oxide. Basic oxide. Basic oxides are oxides that show basic properties in opposition to acidic oxides and that either react with water to form a base or react with an acid to form a salt and water, which are called neutralization reactions. Salt and water. So I have been talking also about auroral precipitation. In other words, the copper playlist, where I ponder about the question of where the copper in Finland came from. As far as I know, I don't know everything. As far as I know, there isn't any volcanoes or whatsoever which would produce copper ore. There are metals in the lavas all over the world, but there are not really copper volcanoes. There are volcanoes where you can find sulfur. For example, Solfatara in Italy, Capi Flegrei, Pompeii, Vesuvio. The Romans gathered their sulfur there because it came from the ground. It is a volcano. No problem with that. There is so much sulfur here in Finland too. So many sulfides. You need sulfur to get a sulfide. A sulfide is sulfur mixed with something else. And there isn't any volcano here. At least not one of those you would consider as a volcano where we have hot lavas and hot springs and sulfur springs and mineral waters and all these kind of things. There isn't any here in Finland. But yet we still have very much sulfides and sulfur and copper in the uppermost layer of the crust, the ground you're walking on. So I have been thinking about the origin of the copper and sulfur, which I discuss in this playlist. Finnish copper might have its origin on Venus or from the interaction with it. Yeah, might sound very, very crazy for people who don't know certain things. I made videos like The Flames Shoot Up to Heaven, where I prove that electricity really has a big influence on rock formations. Yeah, it makes them glow. So once again, there is energy probably coming from above, from the sun. It will enter Earth, and it will flow through Earth's all the layers, of which one is the crust itself. Not only in the atmosphere, we have currents flowing. Every now and then you can see lightning strikes. So there is a lot of electricity above our heads. And in our heads too. So, the thing is about this potassium oxide. Yeah, I really would like. I wish I could tell you because it would be much more easier to explain. But anyway, potassium oxide is something rare. And it has to do something with, I think, clay and stuff like that. So I made a new playlist which talks about clay, because I have been talking about clay to some degree. Craters, deep saline groundwater. And I just told you before that they will create salts. And here in that video, I talk about the surface feature here in Finland, which is supposed to meteorite crater. And beneath, somewhere deep down there, below, there is a huge reservoir of salty water. And not only does Finland have has very, very much peat lands, we also have very, very much clay. Backyard geology vitrified clay. I think there is very nice examples of vitrified clay, and I think they have been created by electrical currents which run through the clay. And it got vitrified. And there are also other things about clay which many people don't know. Many people are familiar with quicksand. But there is also something called as quick clay. It's also known as Leda clay or Champlain Sea clay in Canada. Is any of several distinctively sensitive glacial-marine clays found in Canada, Norway, Russia, Sweden, Finland, the United States, and other locations around the world. Glacial-marine. Yeah. Hopefully you know what I think about glaciers. I think they are lava streams made of water, made by volcanoes. If you want to know more, you have to check out the mountain water playlist or read my paper or do both. Soil liquefaction. Quake clay is found only in countries close to the North Pole, such as Russia, Canada, Norway, Sweden, and Finland, and Alaska, and the United States. And since they were glaciated during the Pleistocene epoch, in Canada, clay is associated primarily with the Pleistocene era Champlain Sea in the modern Ottawa Valley, the St. Lawrence Valley, and the Saguenay River regions. Quake clay has been the underlying cause of many deadly landslides. In Canada alone, it has been associated with more than 250 mapped landslides. Some of these are ancient and may have been triggered by earthquakes. Now let's go down. I want to show you about the Rissa clay incident. And here we have a list. Sarpsborg, Verdal, Rissa. Another famous flow of quick clay at Rissa, Norway in 1978 caused about 33 hectares, 82 acres of farmland to liquefy and flow into the lake bottom over a few hours, with the loss of one life. The Rissa landslide was well recorded by local citizens, and a documentary film was made about it in 1981. So now let's have a quick look at that.
Deposits of marine clay in Norway cover a total area of 40,000 square kilometers. Within this area, quick clay slides represent a serious problem, involving potential loss of lives and property. This documentary film presents the story of such a landslide. It contains unique pictures taken by two amateur photographers who happened to be at the scene. 90-meter length of the shoreline suddenly slid into the lake and disappeared. The debris literally splashed against the lower slide edge and moved like streaming water down the scarp and into the lake. In the background, we can see the barn where the excavation was made. The retrogressive sliding process continued for about 40 minutes. The slide now extends.
So now you got a glimpse of this. And there could be so much still said about the whole thing, but the reason why I talk about this is that we had a quake in Norway. In Glomfjord, 4.6. That's a rather big quake for Scandinavia. And how else could it be? It is on top of a glacier. Mountain water once again. Depth 10 kilometers doesn't really tell us anything. Because 10 kilometers is a basic depth, if they don't want to tell the depth. 10 hours ago, this seems to be a deeper one, 13 kilometers. That's 0 kilometers in depth. So the thing is, let's check it out. Let's do it like that. Let's take the coordinates from that and check out how far away from Rissa it is. So that's the quake location. It's on a glacier. Check it out. Mountain water, anyone? Yeah, but we are probably upside down. So that's the quake location. Now let's put in Rissa. Rissa, Norway. Yeah, it's rather far away from where the quake was. But since we just learned that there's quick clay all over the place, we might have to think about the possibility of something like this going on there too. And one thing also I want to point really, really strongly out is Saltfjellet. Saltfjellet Svartisen National Park. I have been talking about the salt before. Translate Saltfjellet. The Salt Mountain. It's very interesting. So, is there any possibility that the salt and all those reactions or events which created the Earth in the past, especially the northern part of Europe, Scandinavia, with its surface conductivity anomalies, with the occurrences of all kinds of things uranium, cobalt, lithium, copper, gold, you name it, a lot of clay, which is in a way associated to salt. And if we take also sulfur into the whole thing, I made a video about where I talk about this one paper which is about welding, how much difference it makes if there's a little bit more sulfur within the whole process involved. It will penetrate much deeper into the material they are welding. And if we think about the surface conductivity anomaly got created by an electrical discharge, probably the polar cusps smashed down on the surface of Earth, and the solar wind contains sulfur, and there's sulfur like everywhere on asteroids and stuff like that. There is clay on asteroids too. So, and there is a very, very deep moho depth in central Finland, or where I am. It's very deep, 60 kilometers, and it's somewhat also deep underneath those mountains where just the earthquake happened, which is a rather strong quake. And I was very intrigued by this basic oxides, and they are going to create salts. And now we have a salt mountain in Norway with a quake at Glaciers. And there is quick clay in the same country. Why shouldn't there be any quick clay in the vicinity of the quake? Maybe there's gonna be some glacial floods occurring in the same region. I'm just talking about Saltfjellet Svartisen National Park. Yeah, this would be interesting. If there would be something going on, like a glacial flood at the Salt Mountain in Norway. Let's see. But I don't know. It's just like it's hard to make up these kind of things. I just watched the Quake and then I noticed Saltfjellet and I thought, salt? Are you kidding me? Like Norway for salt? Yeah, it's salt. So how is there salt on top of a mountain? Or why? Where did it get its name from? There has to be salt, otherwise people wouldn't have figured out to give this name to the mountain. Yeah. I don't know. Did you, in a way, grasp what I'm trying to explain? And how this potassium oxide leads to the whole thing, and why it's so important for clay, and how electricity and rock forming processes and all these kind of things lead or belong together. It's a very big picture. It's rather hard to explain. I think I have to write something about this. And yeah, let's see. Maybe I have to also present my second paper a bit more here for those who are not readers. There are many people who just are interested, but they are not readers. They're not lazy people, but maybe their thing isn't reading. Maybe they like to watch pictures or something like that. But there are some hints in that paper too, which relates to this theme as well. What to do? All things are related. Where to start? Where to end? What are the things that have to be taken into the picture in order to explain the whole thing? There are many things, and which things are left out because there isn't time or whatever. There's like many moving parts in the whole thing. But a quake in a glacial region in Norway with a mountain called Salt Mountain. Basic oxides create salts, and we have deep salt water occurrences beneath Scandinavia and stuff like that. The influence of sulfur in the depth of the penetration of an electric discharge event. Yeah, which is scalable. From a handheld device to weld to planetary scale. But anyway, I try to make something about this. Check out the other videos. I will link some videos below which maybe help you to understand what I'm trying to tell. And it's hard to tell for me also because I'm just about putting the pieces together which came to me recently through experiences and accidental finds and stuff like that. They're just like appearing. There are many of them, many of them which I try to put together in an understandable way. But anyway, I think I leave it here. And yeah, be careful about quick clay if you don't know about that. I live in the region of quick clay. I learned that accidentally a few weeks ago. What to do? I didn't knew that earlier. Now I know. Thank you.